The speed of light is 3 times 10 to the 8th meters per second. If it takes 5 times 10 to the second, or 5 times 100, or however you want to view it, if it takes 5 times 10 squared seconds for light to travel from the sun to the earth, what is the distance in meters between the sun and the earth? Express your answer in scientific notation. So this is a simple distance is equal to rate times time problem. Distance is equal to rate times time. And I think what they really want to test is our ability to manipulate numbers in scientific notation. So what is our rate here? What is the rate? What is the speed of the thing in question? Well, they tell us right here the speed of light is 3 times 10 to the 8th meters per second. So we could write that down. The rate is 3 times 10 to the 8th meters per second. And then what is the time? The time, they say, if it takes 5 times 10 to the second seconds for light to travel from the sun to the earth. So that's the time. So the time right there is going to be times 5 times 10 squared seconds for light to travel from the sun to the earth. And they want to say, what's the distance in meters? So I just take the product of these two things. The distance is just going to be the product of 3 times 10 to the 8th and 5 times 10 squared. Now, what's fun about scientific notation is that you can just rearrange the numbers you're taking the products, because that's just the property of multiplication. If everything's just being multiplied, order doesn't matter. And so we could rewrite this right here as 3 times 5. I'll try to keep the colors the same. 3 times 5 times 10 to the 8th times 10 to the 8th times 10 squared. And let's see what happens to the units. You have meters per second times seconds. A second in the numerator, second in the denominator. They cancel out, and you're left just with that meters over there. Just with the meters. And that is nice because our answer needs to be in meters. The distance in meters between the sun and the earth. So what's this going to be? So you have a 3 times a 5 right here. That's 15. And then you have that being multiplied by 10 to the 8th times 10 squared. 10 to the 8th times 10 squared, that's 10 to the 8 plus 2, or 10 to the 10th power. So the distance is 15 times 10 to the 10th meters. Now you might say, hey, I'm done. That is the distance. And that looks like scientific notation. I have some number times some power of 10. But remember, if you really want to be formal about your scientific notation, this number right here has to be less than 10. The way I've written it right now, it is clearly not less than 10. So how can we rewrite it? Well, what's 15? 15 is the same thing as 1.5 times 10. Right? That's the exact same thing as 15. So we could write 15 as 1.5 times 10, and then it's going to be that times 10 to the 10th. Times 10 to the 10th power. And of course, we have our units there, meters right there. And now we're really close. We have 1.5 times 10, or we could view that as 1.5 times 10 to the first times 10 to the 10th. And then we have 10 to the first times 10 to the 10th. That is just 10 to the 11th. Right? 10 to the 11th power. So the total distance from the sun to the earth, the distance from the sun to the earth in scientific notation is 1.5 times these guys, which is 10 to the 11th meters.